So just taking a look at this circuit, when the question asks you to solve all of the unknown elements, it's referring to the voltage and current and resistance across every one of these loads. So notice that for something like this, we can't actually inherently use Ohm's law because we don't know 2 out of 3 for any of these loads. And we can't actually do anything with current law or voltage law because the current we don't know anything about. And even though we know the initial voltage for a charge that's passing through this branch in the circuit, I don't actually know any of the individual voltages, so I can't determine how much gets distributed to each one. So in this case, the only thing that we have to do is first solve for the equivalent resistance. We need to know what the total resistance of this circuit is, because once you do, if we know the total voltage and the total resistance, then we can use Ohm's law to figure out the total current and distribute that current using all of our tools. So let's take a look at how we did that over here. So here's the initial setup of the circuit. We recognize that we have 2 resistors that are in parallel with each other, so we're going to combine those into a single resistor, which is what we've done here. You can follow the math. So that creates this equivalent circuit. Okay, so it's the original circuit, but then this resistor is now an equivalent resistor. I've colored it different so it stands out. And now we see we have 3 resistors in series with each other, so we're going to use our formula to combine those together. So now that has created an equivalent circuit with a total voltage of 10 volts and an equivalent resistance, which I'm calling R1234, which is all of them combined into one, 58.75 ohms. Now, given that we know the total voltage and the total resistance for the circuit, then we can figure out what the total current is just using Ohm's law. So we end up with a total current, at which point, since we know the current that's coming out of the source, we can go back to using Kirchhoff's current law, Ohm's law, and Kirchhoff's voltage law to solve for the unknown values. So just as one example, I'm not going to solve it all here. If we know how much current is coming out of this battery, and there's been no junctions or break in the circuit, then there must be that same amount of current passing through this resistor. And similarly, even though the circuit splits, the circuit recombines over here, so we know that it must be that amount of current flowing back into the battery. So if this is a known value and we've just determined this by the voltage law, then we can use Ohm's law to figure out this voltage. Similarly, we can use Ohm's law to figure out this voltage. And then we're back into Kirchhoff's voltage law, which tells me that the voltage here and the voltage here and the voltage here should all add up to 10. And so that allows me to figure out this unknown. And in using these processes of voltage law, current law, and Ohm's law, we come up with this final answer here.